In this tutorial, we are going to extract relatively accurate topographical or geographical data from Google Earth using Google SketchUp, and then import that data into Rhino 4.0. So to start, I've opened a new SketchUp file. Delete this person. First thing we want to check is model info. We want to make sure we're using millimeters. That's all fine. And I would preface by saying this is pretty much the only thing I use SketchUp for, but this has been the most accurate way and easiest way I found to access this data. I'm using just the free version of SketchUp. It's not necessary to use the pro version for this. So if you look up here at the top, there's a button called Add Location. I'm going to do that. And I'm going to use Mount Dansha in Guangdong Province, China. But it has the entire world's worth of data. You can see there's this white rectangle, or white square. That's the boundaries of what Google will let you download at one go. So it's 1 kilometer by 1 kilometer, and I guess because of copyright agreements or whatever, you're not allowed to download more than 1 square kilometer at a time. But that's fine, we can stitch things together relatively easily. So I'm just going to set it here and click Select Region. Click Grab. You can see it's placed the image into the Google SketchUp document. Next to this button up here is the Toggle Terrain button. We're going to put that on. You see now, you can see how we have this 1 square kilometer of actual terrain coming from the model. But assuming we want more than this 1 square kilometer by 1 square kilometer, we can add more imagery. And then just drag and select a new region. Grab. This is fine. Okay. You see it's stitched the model together next to our original patch. They're overlapping a bit, and that's fine. For what we're doing, that's not a problem at all. We just want to make sure we're grabbing a big enough area, and then when we import into Rhino, we can work with a smaller subset of that area. So let's add more imagery again. Okay. And one more time. Okay, so now we have more or less 2 kilometer by 2 kilometer patch. You can see we've got watermarks here from Google. That's fine, as we're just using this for academic purposes, and you won't be able to see that in the final model anyway. So that's all we need from. Now if we go back to model info and click on geolocation, we can see this model is accurately geolocated, country China, Guangdong Province, and latitude and longitude, which is referring to the point of origin here where the red, blue, and green lines intersect. So that's the precise, accurate dimensions and location for this particular patch of land. So that's all we need from Google SketchUp. Now we can save as. I have better results saving as SketchUp version 7, and we're just going to be importing this into Rhino. So let's just save as SketchUp version 7. We can close SketchUp. And then in a new Rhino file, again using large objects in millimeters, we can import, just typing import into the command line. And import the SketchUp model. We'll click on perspective and zoom out. So we can see that we've got these 4 overlapping patches. We go into shaded view. For some reason it's put these flat surfaces in as well. Select everything, right click, type ungroup, and delete these 4 surfaces. We now just have a mesh file from SketchUp. Go back into top perspective, and again if we add a point at the origin 0, 0, we can see it falls right in the middle of this first quadrant. So this point here, the origin in Rhino, is representing the same origin that we had in SketchUp, which is still applicable to the latitude and longitude coordinates. So what we're going to do here is we're going to do a drape command. Just type drape, D-R-A-P-E, and auto spacing yes, spacing 5 should be fine. And we're just going to, like it says, drag a window over area to drape. Just drag a window that falls completely inside of the boundaries of the 4 quadrants. If we go back to perspective viewport, you can turn off this layer from Google Earth. And now we have a single clean NURBS surface that represents our geometry.